Namaskar, my dear friends. So let us talk about C2000 microcontroller schematic design. So what we have done is we have taken a microcontroller TMS320F280037. So this is the microcontroller series which is very popular, okay? And we will be taking one of the target device which is going to be F280037 SPT, and this is going to be 48 pin LQFP package, okay? So what we'll do is we will try to understand what is the step-by-step process of circuit design and how to design microcontroller system very accurately. All right. So in this session, you will also understand what is the different approach or different procedure, like to follow so that you can design your microcontroller circuits very easily, just like what I'm going to show you right now. This, okay. So we have a very nice, like a microcontroller symbol. We have peripheral interfaces, all the pin mappings, and all other parts. So we will explain one by one what are each of the sections. Okay. So first we will try to understand the theory part, and then we can go through the circuit design as well. So basically what we'll do is we'll be talking about this particular microcontroller as a like a focus device, and then we will be designing power supply connector, power supply management. Then we will have lot of other peripherals like potentiometer. We will add like 6 PWM generation so that we can drive full bridge circuit for motor drives. We will have temperature sensor, CAN transceiver, LIN transceiver. We have ADC interfacing, okay. Then we have reset circuit for microcontroller, audio buzzer for alarm purpose or something. We'll also generate DAC signals so that like you can drive some of the DAC interface requirements. We will have EEPROM based on I2C interfaces. We have external interface so that you can take out those PWM signal to outside board like daughter board. Then we'll also like have little bit interfaces for deep switches, push buttons, LEDs, and the most important part is how to program my microcontroller, that JTAG interface. Okay, so if you go through, if you want, you can take a screenshot of this and have a like a reference for yourself so that you can start designing one by one block. Now let us say what are the things that we are going to do in our session. So basically, we will be having our design requirement, like what is required. So just now I explained you the block diagram. This block diagram is our requirement. So this is how you actually, put things in your database. Then how to start microcontroller design, how to start your microcontroller circuit design, what are the different approaches, okay, how to assign pins for different functionalities. Pin mapping is very difficult task sometimes, but now it has been made very easy by the manufacturers because they provide software tools, as well as the dataset itself is well explained, okay. Then how we are going to interface peripherals. Let us say basically like based on system design requirement, what we'll do is we'll do the programming, reset, decoupling capacitors and power supply that will be required for my microcontroller, okay. We'll also understand the power supply like management, basically how much is the current consumption that is needed so that you can design your like voltage rails or regulator voltage regulators. So what are the different voltage rails that will be needed in the system, and whether it is going to be a switching regulator for yourself or linear regulator. That is a big task to understand or differentiate or compare between these two, okay. Based on the heat dissipation and current consumption requirement, we select either switching regulator or linear regulator. We'll also try to understand in these peripheral connections, just like I told you, like ADC, alarm buzzer and temperature sensors. And then we will be having EEPROM, okay. So this will be used for storing our live data or something like that. Then other parts we will try to interface is LED, push button, deep switches, PWM outputs and external interface as well. And similar to that, we will have DAC, how to interface with DAC output, voltage reference generation. Then CAN transceiver, okay, voltage level shifter will be required, ESD protection will be required, CAN TX, CAN RX signal will be needed. Similar to CAN transceiver, we have LIN transceiver as well. So this LIN transceiver also will be doing the same job. We will have LIN transceiver interfacing. So let us directly get into the circuit design and see what are the things that we have. So let us start the first type, first one. First job is we have to design this particular symbol. Okay, so in a software you can design this particular symbol based on the data sheet that you have. So this is the data sheet of this particular microcontroller that I am going to refer, and this is the device that I am referring to. Okay, this one. So this is a TMS320F28003X series. So 3X means 3, 9 and 3, 7 both are there. So we will be like dealing with 3, 7 right now. We'll deal with 3, 9 in our next sessions as well. Okay. And how to do pin mapping and everything that I have showed you in our theoretical class. So we will have that as well. But in application, if you see, we have different kinds of application that is there, like air conditioner or motor drives or anything that you think of where motor drive is needed. This is the particular like microcontroller that will be serving the purpose. Okay, so let us get into the circuit. Okay. So very first thing is all these are ADC pin. We have three ADCs, A, and B and C. Okay, and then similar to that we have GPIOs which have a capability of generating the EPWM. Okay, enhanced PWMs. Okay, so very first thing that we have to do is programming. So programming is JTAG programming. So this 10 pin connector will be serving as a JTAG programmer, and this will be requiring TMS, TCK, TDO, TDI and XRN, that is your reset signal circuit. So this is the interface for that. Hope you have a good understanding now how to interface JTAG circuit with our microcontroller. Next, if you want manually, you can reset this particular microcontroller if you want. So in that case, what you have to do is you have to design this particular push button circuit. So once this goes down, it will be grounded, and this is how it will pull it down. So similar to that, it will be resetting the microcontroller. Next comes up is like decoupling capacitor. So this is my VSS that is going to be ground, and this is my VDD-IO. VDD-IO will be requiring 3.3 volts. So what I have done is, this is a VDD power supply which is 3.3 volt. So this is going to be filtered like through a ferrite bead, and then VDD-IO is coming. So this VDD-IO will require 3 pins are there. So 3 decoupling capacitors plus 1 bulk capacitor is there. Okay. Similar to that, this VDD will be requiring internally generated. Okay. So it will be VDD MCU. This is just a net name. Okay. To connect it. And this is the decoupling capacitor externally. You don't need a separate voltage for this VDD pin. Okay. Similar to that, VDD-A, that is your analog pin. So analog pin require one more filtered output. So you can see here filtered capacitor is there. Filtered output is there. I mean ferrite bead. And then we have decoupling capacitors as well for that. Similar to that, they say about like reference voltages. So reference voltage I have directly connected like a VDD-A. Okay, so I have not generated separately for that. And then what you can do is about other parts, let's say DAC. So DAC, I have generated a separate reference device, reference like voltage, Vref DAC. Okay, so that will be 3 volt. And then we have two DACs, DAC A out and DAC B out. So these two I have utilized for my purpose. Similar to that, other parts like we have like pin mapping. So pin mapping, you can see we have potentiometer, we have like voltage measurements. So instead of explaining here, what I'll do is I'll explain the circuit section, and then you will be able to understand properly. Okay. So let us say we have a requirement of audio buzzer. So audio buzzer, what it will do is it will directly like this PWM signal, one of them I have taken, and this is going to be go here. Okay. So actually you make it 0 ohm. Okay. So this 0 ohm will be sending it here, and this is my PWM of 2.7 kilohertz. 2.71 kilohertz you can generate, and you can start running this. So this is a well defined circuit, well like a verified circuit. So this runs very nicely. Similar to that, we have potentiometer. Okay, so this potentiometer is going to vary 10 kilo ohm, and based on that ADC value will vary, and this ADC value you can utilize for your purpose. Similar to that, we have measurement of our voltage level. So 5 volt is there and 3.3 volt is there. So with a proper voltage division, and then sending it through a buffer circuit, then filter circuit, and then it is going to my ADC pin of microcontroller. The same process is followed for 3.3 volt also. So this is how you can keep a monitoring of your voltage levels on your circuit. Okay. Then if you talk about temperature sensors, I have put on board one temperature sensor. This is going to be very popular. This actually gives you 10 millivolt per degree centigrade. So for 1 degree centigrade change, there will be a variation of 10 millivolt. This is how you will be able to find out what is the temperature to send it to your ADC. We have an external, like EEPROM. So this 4 kilo bits of EEPROM is there through I2C interfaces. Okay. So all right, this is how it is done. Coming back to the IOs. So we have two push buttons, push button 0 and push button 1. Okay, so this is how it is going to get connected. So I have put not connected because I don't have much pins, and if you want it to utilize, you can connect it, remove this NC, so it will be connected there. Okay, so this is how it is designed. Similar to that, we have deep switches. Okay, so deep switches are actually used to have the status on a pin, let's say 0001 1011. So basically these two deep switches will serve you to give four status of the like a 2 GPIOs. Okay, then LEDs I have connected through MOSFET so that it doesn't like consume any current from the IOs of our microcontroller. So user LED IO is there connected to my microcontroller, and this will go high. So this is how my MOSFET will get switched on, and this is how LED will start glowing. Okay, so this is how it does. Same way three LEDs are connected. Moving to the next part, we have CAN transceiver. Okay, so this CAN transceiver will require 5 volt signal. So what we have done is this CAN TX, CAN RX is coming from my microcontroller, and this is going to have a voltage level shift from like 3.3 volt to 5 volt. Okay, so VDD is 3.3 and VCC is 5 volt. And this is going to get connected TXD and RXD. So it is going to give you CAN high and CAN low in this particular connector, so you can utilize for your purpose. And this is ESD protected as well, so that's the reason I told you like ESD protection of your CAN transceiver. Okay, so good. So this is how it is done. Now talking about LIN transceiver, so we have one LIN RX and LIN TX signal. Okay, so LIN RX, LIN TX signal is there, and this is my LIN transceiver, very popular LIN transceiver, and this is also like ESD protected, and this is my power supplies. Okay, so VBB is power supply for that. So this LIN bus is taken to this particular connector, and this particular connector itself is giving you the interface for your DAC signal also. So DAC 1 and DAC 2 you are taking out. Coming back to the power supply, so power supply is very important task. Okay, so you have to understand how power supply is designed. Okay, so basically we have a connector input so that you can give a power supply up to 6 volt to 18 volt. Okay, or otherwise you can put a adapter jack also, like a 12 volt is very sufficient for that purpose. Okay, then after a fuse protection and everything, we have V in A. So V in A is coming here, and this is going to get generate through this particular switching regulator, which is going to convert 5 volt to ampere output. So this is how the well designed switching regulator for your microcontroller system purpose. Okay, and this 5 volt is going to act as a input for 3.3 volt regulator. So this 3.3 volt regulator will be giving you 0.5 ampere of current rating, and also we have put a LED for power supply monitoring. So if this LED is glowing, it means you will understand that okay, 3.3 volt is available. And similar to that, we have reset N. So similar to that, this LED will also glow 5 volt. So if it is glowing, it means you will see that okay, we have 5 volt available. If it doesn't glow, it means it will be going low. Okay, so this is how 5 volt generation is also done. So hope you have now a understanding of how you have completed your complete circuit design for this particular microcontroller that we have in our mind. Okay. So let me go through quickly. So what you can do is you can take these into account and try to design your microcontroller circuit, and if any other interfaces is needed, you can have an understanding for that as well. Now let me quickly give you how you can interface the pin mapping. Okay, so basically you go to data sheet, and whichever signal is needed, come to the like pin attribute. So this is called signal description pin attribute. It is there on pin like pin number 36. Okay, so any of these microcontroller you're working on, you can come here, and if you have to put ADC signal, any of these A0, A1, A15 up to, you can supply this. Okay, so this is 100 pin and this is 48 pin. So this one is the one which is our focus area. Okay, so pin number 11, 10, 6, something like that is the understanding. Similar to that, other signals, let us say we have B0 ADC is also there, we have C0 ADC is also there, we have compare, capture and compare, then we have other parts also are there. Okay. So it is alphabetically maintained. So this is how you can do that. See DAC output signals, or which pin is corresponding to DAC, you can see pin number 11 and pin number 10. So you come to here and see here pin number 10 and pin number 11 is there. So 11 is A and 10 is B. So you can see 11 is A and 10 is B. Similar to that, other parts like PWM. PWM is one of the important tasks. Okay. Before that, let's say CAN. So CAN is there, CAN ARX, CAN ARX, CAN ATX. So these are the pins that is supporting your CAN signal. Okay. So you can see we have 25, 31 and all these things are there. So you can see which one is connected here, 33, 34. So 33 is this one and 34 is this one. Understood? So this is how you have mapped it. Similar to that, we have these many pairs of PWM. So you can see whichever PWM you want, you can connect to that particular pin for PWM output. So all right, you have now a good understanding of where to look for what information and how to start circuit design for yourself. Okay. So thank you guys. If you do have any questions regarding the circuit design for this particular microcontroller system or any C2000 series microcontroller system, you can put down your comments in the comment box, and we shall be able to give you a proper solution as soon as possible. Thank you.